Hi and good day everyone. So today we're going to explore, to explain and to elaborate a component that we learned from analog electronics, which is 20 oscillator. But before we get into it, what exactly an oscillator? An oscillator is an electronic circuit that generates a continuous periodic signal, usually in a form of sine wave or square wave as shown in figure below. So that is an oscillator. So now, what is a 20 oscillator? A 20 oscillator is one of the kind of oscillator, but use a specific arrangement of resistor and capacitor to generate a sine wave output. It is called 20 because of consistence of two T network as shown in figure below, which is connected in parallel with help to determine the frequency of the oscillation. So now let's talk about what is benefits and limitation. So the benefits of 20 oscillator, firstly, is how simple it is. 20 oscillator has a very simple design, which is making it easy to build and to understand. Secondly, of how cheap it is, because 20 oscillator only use a very simple component in it, so it's making it very cheap, very inexpensive, and very easy to find. And lastly, of how pure sine wave output that can it make. It generates a clean and stable sine wave, which is desirable for many applications such as audio and signal processing. So now, the limits of this circuit is, firstly, 20 oscillator is meant for a lower frequency circuit and may not perform well in very high frequency. Secondly, the frequency stability can be affected by temperature variance and component tolerance. And lastly, the oscillator performance is sensitive to exact value of the resistor and the capacitor, which can lead to variation in the output frequency, which may not be the exact value. That's all from me. Let's move to the next.
The diagram provided is a schematic of a 20 oscillator which use an operational amplifier op-amp along with the resistors and capacitors to generate a sinusoidal waveform. Here's a detailed explanation of each part of the circuit. First, operational amplifier op-amp. The op-amp provides the necessary amplification and feedback to sustain oscillation. Secondly, 20 network. This network consists of two resistors R and two capacitors C arranged in a T configuration. The resistors and capacitors form two arms of the T network, creating a band-pass filter. Third, feedback resistor R1 and R2. These resistors set the gain of the op-amp. The ratio of R1 to R2 determines the overall gain of the feedback loop.
Okay, for this part, operation of circuit, as we can see in the slide, this is the circuit of 20 oscillator. Okay, why we call this 20 oscillator? Because there is two T network in the circuit. Okay, one you can see one with capacitors and resistor in series and one with resistor and capacitors in parallel. Okay, this circuit is a combination of low pass and high pass. Okay. So as we know, the output for high pass, a combination of high pass and low pass, it is called band pass, right? Okay, for 20 oscillator, the specific name for the output is notch pass. Notch pass. Okay, like the picture above, we can see that the starting output is in low pass and then the high pass. So it produces the U shape. Okay, so for the frequency, we use the formula 1 over 2 pi RC, which is resistor and capacitor.
Okay, I am going to talk about the important formulas associated with the 20 oscillator, which is a common configuration in the electronic circuit used to create oscillation with a specific frequency. First, let's understand the resonance condition for the 20 oscillator. This oscillator use a combination of resistor and capacitor in two T-shaped network. This network work together to create a feedback loop with a specific phase shift and gains, which is essential for oscillation. The key to design a 20 oscillator is understanding the frequency at which is oscillated. Also, know the center or no frequency. This frequency can be determined using the formulas for the low pass RCRC network and high pass CRC network. For the low pass network, the cutoff frequency FC is given by FC 1 per 2 pi square root 1 per C 2C R square. This is formula. C represents the capacitor and R represents for resistor in the network. The arrangement of the resistor and capacitor determine the specific frequency at which the network will allow signal to pass through. Next, for the high pass network, the cutoff frequency FC is expressed as FC equal to 1 per 2 pi square root 1 per C square R per 2 R plus R. Against, C is a capacitor and R is resistor. This network allow high frequency signal to pass while attenuating lower frequencies. Combining these two sets of equations together give us the final equation for the null or center frequency of the notch, resulting in oscillation for the 20 network. This is a critical achieving the performance and applications such as signal generator, audio equipment, and various other electronic devices. Now, let's break down the fundamental formula for the frequency of oscillation in the 20 oscillator. FC equal to 1 per 2 pi RC. FC is the frequency of oscillation in Hertz. R is the feedback resistor in ohm. C is the feedback capacitors in farads. Pi is a constant with a value of approximately 3.14 to 1. Understanding this formula and the interplay between the low pass and high pass network allow engineers to design 20 oscillators with the precise control over their oscillation frequency. Thank you for your attention.
Let's look at application of the oscillator. First, signal generation. 20 oscillators are often used in signal generators to produce sine waves for testing and development purposes in electronic circuits and systems. Second, audio applications. Due to their capability to produce low distortion sine waves, 20 oscillators are widely used in audio applications such as tone generators, audio testing equipment, and musical instruments. Third, phase lock loops, PLLs. In PLL systems, 20 oscillators can serve as reference frequency sources, helping to stabilize and control the frequency of the PLL. Fourth, filters. 20 networks are used in band pass and band reject filters. When used in oscillators, they can help in selecting specific frequency components from a signal. The fifth one is frequency modulation FM and amplitude modulation AM systems. They are used in modulation and demodulation circuits within FM and AM systems, providing a stable frequency reference. And sixth is measurement instruments. 20 oscillators are incorporated in measurement instruments for precise frequency generation, aiding in the calibration and testing of other equipment. Seventh is medical equipment. In medical electronics, such as ECG machines, 20 oscillators are used to generate stable frequencies for signal processing and analysis. And the last one is communication systems. They are employed in various communication devices and systems to generate carrier signals and for frequency synthesis.